Welcome to Your Space Journey, where we venture into the future of space exploration and the incredible leaders who are taking us there. Here's your host, Chuck Fields.
Hello, thanks for joining me today. It is my pleasure to introduce my special guest, Eli Naffah. Eli is Chief of the Space Communications and Spectrum Management Office at NASA Glenn's Research Center. I was fortunate to go on-site at NASA Glenn to join Eli so he could discuss one of NASA's newest programs, the Communication Services Program, or CSP. As more commercial companies evolve services and infrastructure in near-Earth orbit, NASA has created CSP in order to develop a commercially led space communications capability for its missions. I had such a great time talking to Eli, but of course I had to ask him where his space journey began. Here's Eli discussing that.
I remember as a child, we used to, in elementary school, we used to get a break every time the astronauts would do something during Gemini and Apollo. I remember the moon landing. I was 7 years old, and from that point on, I knew what I wanted to do. I wanted to be an astronaut, but didn't quite make it that far. But I wanted to be part of this great team that went to the moon. And to this day, I've always still wanted that. So, and I'm amazed that I was able to be a part of the NASA team.
Now, of course, Eli has an incredible NASA career that began at John F. Kennedy Space Center as he worked even on the Space Shuttle program. And then now, of course, he works at NASA Glenn, helping out with Artemis as well. Here's Eli talking about his incredible career at NASA.
You know, I always liked science and math, and I was a space nut as a kid. You know, I couldn't get enough information about the space program and about science, and I used to get science news and space news. So I went to school at Central Florida, University of Central Florida, for aerospace engineering, and I started co-oping at Kennedy Space Center. I recommend that for any students that are interested in in any career, but it's a good way to start at NASA through the Pathways program, which is our co-op program. The internships is an excellent way to get started, and so that's how I got started. I worked in the shuttle program on the Space Lab. So we were part of a kind of an experimental group that where NASA young engineers could get hands-on work with flight hardware, and so we would put flight experiment hardware together for the Space Lab program, and so you could actually turn the wrench and do the testing, and then later you saw it fly, and then you saw it come back, and you took it apart, and so that was a very exciting way to start my career. At Kennedy Space Center, and then I was originally from Cleveland, so I wanted to come back home, and there was an opportunity with the International Space Station. We were one of the work packages for the power system, which is actually the power system that's flying now, was developed here in Cleveland, and I was part of that team that did that.
Now, the Commercial Services Program is brand new. So I asked Eli to give us a basic overview of the program. Here he is discussing that.
Well, Glenn Research Center, before that was Lewis Research Center, has always been very much engaged with industry on the communication side, the SATCOM side, And in particular, one of the things we did about 20 years ago was Advanced Communications Technology Satellite, ACTS, which was a revolutionary experiment that we did with industry. And it was mainly to help industry to open up a new band, the microwave band, which is called KA, high frequency, higher data rates. There's technological problems with doing that, and we kind of mastered that and developed a new architecture, which created a new era for space for SATCOM. For SATCOM on the commercial side, direct TV, broadband communications, it enabled a lot. So over the last 20 years, industry's been investing a lot of money because there's markets, the cell phone market,
Exactly.
the direct TV market, and they've also been, doing similar things for industry. Excuse me, for the military. So there's a lot of infrastructure out there now that didn't exist in the 80s. And so, for example, the Space Network, which is a network of geostationary satellites, relays, that the first one was launched in the 80s. The intention there was to create continuous service for manned spaceflight, human spaceflight. And so that was in particular driven by the shuttle. In the old days, they used to just be able to, they used aircraft, ground stations, ships at sea to try to get continuous coverage, and occasionally they had loss of signal, and they didn't want to have any loss of signal with the shuttle. So some very smart people at Goddard Space Flight Center created the TDRS, the Tracking and Data Relay Satellite, and they created a system of satellites in geosynchronous orbit, which is extremely capable and has been taking care of the space station and other NASA needs for years. Okay, but that is mainly 80s technology. Okay, and we launched our last TDRS in 2017. So that was TDRS M. And so at some point, and we're projecting maybe around 2025, the capability, the capacity of TDRS will start to diminish, given that we'll start to lose spacecraft. Okay, we've got I think 7 active TDRS right now, and so we'll start to lose capability as they get older, and as they get older, we'll need to bring something new on. And so the idea for the Communication Services Program was to try to wean ourselves off of the government-owned and operated systems and look to industry to provide those services that we need for common nav in space. And so that's the goal of the Communication Services Program, is to investigate the feasibility of being able to utilize the industry assets, and instead of owning and operating our own systems, which is costly, to be able to procure those services.
Now, a brand new program such as this obviously has tremendous undertakings, from budgeting to creating a new market for this industry. Here's Eli talking about that.
This new program was in the President's budget for start in 2020. And we just recently received an appropriation from Congress to formulate. So we're in the process of formulating the new program. It's being funded out of the Human Exploration and Operations Mission Directorate, and Glenn is supporting that activity as the primary center, and I'm leading the formulation team. So one of the things we wanted to do is we need to create a new market. So currently, the way it works in industry, the SATCOM industry, is they're typically generating content on the ground, and they're sending it to a satellite in space, which is a relay, and then they're broadcasting that back down for streaming or direct TV. What we need to do is, so that we can be one of many buyers, we need to create a new industry. And that industry is to provide services for spacecraft. In other words, communications and navigation services for spacecraft. So instead of creating the content on the ground, the spacecraft are creating the content in space, okay, and getting it down to the ground, or the ground is sending commands to the spacecraft, and the spacecraft is navigating. So we need to have those services which are provided to spacecraft, and the hope is that by creating this new industry, it'll help our economy, okay, spur economic growth, okay, and in addition to that, then we could then buy some of those services which they're selling potentially to the military, selling to commercial space, and selling to maybe other foreign space agencies. that's the hope, that's the goal, and if we're successful in doing that, then our costs will come down.
Now, creating a new industry is a huge endeavor. And Eli says CSP is ready to lead, and they're going to leverage that investment. Here's Eli talking about that.
We believe that industry is ready to lead. When we started with the tracking and data relay satellite and the space network in the 80s, there was very little infrastructure out there and very, very limited capability on the commercial side. And so NASA had to do it at that time. But right now, there's industry is outpacing us in many ways. And so the idea is to try to leverage all of that investment for NASA purposes.
Now, as you may or may not know, NASA actually manages 3 networks: the Deep Space Network, the Near Earth Network, and the Space Network. Here's Eli talking about those in more detail.
Currently, NASA owns and operates 3 networks: the Near Earth Network and the Space Network, which are managed by Goddard Space Flight Center, and the Deep Space Network, which is managed by Jet Propulsion Labs. And so the idea is that in particular, and I think you're starting to see an evolution at NASA going towards commercial space, and in particular in the low Earth orbit regime. NASA's not the only one playing in that regime anymore, and there's a lot of interest by the commercial sector, a lot of investment by the commercial sector, which we're leveraging, which we've leveraged for commercial crew currently, and in the past, and we've been successful to do commercial cargo to ISS, and so now this is the next evolution, commercial communication services.
Now, the space communications industry is changing fast, and CSP is actually changing the model to handle that. Here's Eli discussing that in more detail.
The idea is there's been billions of dollars spent by industry over the last 20 years, and there's a very big infrastructure now of ground stations, satellites, and networks that are being established, and it's growing. The industry is growing. In many ways, they're ahead of us, okay? And so the idea is to tap that, to tap that market, and in essence, I think when you look at the way things are done currently by industry, they're mainly interested in creating content on the ground, and then they use spacecraft relays to relay that and then broadcast it down for purposes like DirecTV and cellular service streaming. What the difference is we're creating the content in space, okay, and we need to get it down to our scientists here on Earth, or we need to generate commands that we're doing here to the spacecraft and get it to space. So it's a slightly different model than what industry is currently doing, okay, but the infrastructure is there and could be adapted, okay, and that's what we're looking to try to do.
Now, while some of the aspects of CSP have already started, it will obviously take several years before the full program is implemented. Here's Eli talking about the timeline of CSP.
We would hope to have within the first 3 years, 2 to 3 years, demonstrated some capabilities that we can then go out and acquire services for, okay, and start bringing NASA missions into commercial services. And I would say by 2025, we'll need to have services that can augment what we're currently doing with the space network, because we'll start to see a decline in the space network, and we'll need to make sure that NASA missions are covered, okay, as we go forward, as TDRS begins to decline. By 2030 timeframe, I would say we would expect to have a full slate of commercial services that would be able to satisfy NASA's near-Earth communication needs.
Now, of course, there's program challenges for something of this magnitude. And one of the first ones is, of course, how to ensure quality. Here's Eli talking about that.
We need to be able to ensure to our missions that the quality of service, the performance, and the longevity, the reliability of the service is there for them, Okay, and so that's going to be a very difficult task to do. Okay,
Absolutely.
also, our networks do a good job. In particular, the space network is, with TDRS, there's a huge antenna up there that basically can be dedicated to a spacecraft in low Earth orbit. Okay, when you got a huge antenna, which is a big pipe that is looking at and tracking a low Earth orbit spacecraft, the burden on that spacecraft is very low. Okay, so our users like that. They don't want to have to use a lot of power or mass to be able to communicate with either the ground or for their telemetry or for their command. Okay, so it's likely that industry is probably not going to do it the same way we're doing it. Okay, currently. All right, they're going to find a different way to do it. And so proving to our missions that the different way of doing it is going to work just as well as the current way is going to be very difficult.
Now, in addition to ensuring quality, there are, of course, some technical issues that CSP has to solve. Here's Eli talking about that.
There are also issues, there's technical issues, obviously. We do some similar things currently now, the industry does with aircraft. They have relays that are broadcasting down to aircraft through spot beams.
Right.
Okay, and that's your internet that you get on aircraft. Well, a spacecraft's going a lot faster than an aircraft, and the beam is narrower at in higher altitudes. So there are Doppler effects. There's typically a spacecraft could be going through a spot beam in less than a second, and so to acquire, authenticate, and transmit or receive in less than a second and then keep doing it without losing continuity, those are the kind of issues that we may face.
Now, with the ever-growing need of communications, frequency becomes a problem. We also call that spectrum issues. Here's Eli talking about how they're going to handle that.
There are also spectrum issues associated with this. So typically we use government frequencies. We operate there's technically no government frequencies, but there are frequencies for space research. We use those frequencies.
Okay.
The commercial sector uses frequencies designed for fixed satellite systems, mobile satellite systems, that they're on a different frequency range. Right. And so whether we use their frequencies or our frequencies is a question. Okay, that we'll have to answer, but there probably will be regulatory issues and things that we'll have to deal with in the World Radio Conference to decide whether or not we can use a certain frequency for space-to-space communications where we don't have an allocation there, and that can take years.
Wow. Eli, it sounds like you and your team have a lot on your plate for the next couple of years. We just want to wish you and your team the best of success for this. I want to thank you so much for taking time to join us. I really appreciate it.
Thank you. It's my pleasure.
Your space journey.
Well, I really enjoyed my conversation with Eli, and of course I enjoyed going to NASA Glenn. I want to thank Eli for joining me in that discussion. And we're excited about the Commercial Services Program. That's going to be a certainly neat program to watch, and it's going to just transform the industry in the future years. I want to thank Eli for joining us today to discuss this. I want to thank you for joining us as well. Again, we'd love it if you'd share this episode with a friend, help us get the word out. If you can rate us on your favorite podcast application, that'd be great. If you're watching on YouTube, just give us a thumbs up and a subscribe. We'd appreciate that. Either way, thank you so much for joining us today. We'll see you next time. God bless.